All right, well, welcome everyone to Air and Water Purification for a Healthy Home. This is approved for 1 hour in continuing education units GBCI, AIA HSW, AIBD, NARI Green, Certified Green Professionals, and may be applicable to your state-based design or contractor license. My name is Brett Little, and I am the Executive Director here at the Green Home Institute. I'll be your host and moderator today. The Green Home Institute has been around since 2000, and we are a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We want to thank our major Platinum Plus sponsor, Andersen Windows, and Renewal by Andersen Windows and Doors. Check them out for all your fenestration needs. Want to throw you over to help support and keep these continuing education sessions going by becoming a member, which comes with other benefits, as well as taking a look at becoming a certified green home professional if you are someone in the industry of making homes better. Check that out, both of those on our website. So with that, I do want to introduce our speaker today. We had 2 speakers lined up, but just 1 speaker today on this session, Andrew Pace. He's an entrepreneur in the Milwaukee suburb of Waukesha, Wisconsin. And for the past 25 years, Pace has studied and dealt in green and healthy home building and improvement products, and has earned a reputation as a national expert on such products. Along with being profiled in numerous publications, Pace has authored several articles about construction of healthy homes, which have been published in regional and national magazines such as Environmental Design and Construction, Ecological Home Ideas, and Paint Dealer magazines. Further, his insights have been chronicled in print publications such as Home Improvement Magazine, based in Dallas, and the Milwaukee Journal Sentinel, Small Business Times, and others. Andrew is calling in and representing the Green Design Center, and with that, I will hand it over to him to take it away. So thank you, Andrew.
Thank you very much, Brett. Once again, I appreciate being involved in a presentation with the Green Home Institute. As Brett said, I've been in this industry for about 25 years. I started a company called Safe Building Solutions way back in the early 90s, and I started it because of the need to find healthier alternatives to traditional building materials. My background is architecture and commercial construction, and we were working on a project in Milwaukee where several of the contractors involved applying an epoxy floor coating got rushed to the hospital because of inhalation complications. And it turns out that this water-based epoxy coating that they were using was actually highly toxic still. And, early 90s, we all thought that water-based meant safe, and that's certainly not the case. And that's what brought me to the realization that we need to clean up our industry. So with that, over the years, we've worked with a variety of manufacturers. We've found other methods and materials to help build healthy homes. So my expertise is in general knowledge of construction materials. I will say this outright, when it comes to air and water purification, we work with a lot of companies and a lot of systems. I am not an air quality chemist. I am not a plumber nor a water quality chemist. However, we get asked by thousands of customers across the country every year for our recommendations, just because of that reputation that Brett was referring to. So let me start this presentation this morning and show you what we're going to be talking about today. We're going to talk about just some basic things. There's so many systems on the market today. I think that people get confused. They do a Google search for air or water purification devices, and you get inundated with the sales sites, and it's really difficult to find some definitive, black and white information about this. So we're going to talk about assessing what your clients are looking for air and water purification. We'll determine what the proper choice is for both air or water purification, the different types of media out there, the different types of equipment that can be used. And when it comes to choosing the correct water filtration product, what does the customer really need and what's going to work best for their situation? And I will say this too, like Brett said, as I'm discussing these items, please feel free to throw out some questions. And there's a lot of data and documentation that I put together for this presentation on my end. I didn't really want to put it into the PowerPoint because it's a lot of words and a lot of numbers and a lot of chemicals, and so those things I can certainly email to everybody after the fact. So what does a client need? When a customer comes into one of our showrooms and they're either building a home, remodeling a home, and we're looking at specifically right now from the water standpoint, one of the first questions we're going to ask is, well, do you have well water or is it city water? In both situations, we're dealing with certain things we're trying to filter out, but both also have some very specific requirements. With well water, when a client asks us to provide a water product or a water filtration system, it's usually because from a chemical sensitivity standpoint, and if any of you were at our last talk about chemical sensitivity, that's really our expertise in working with people with allergies, asthma, chemical sensitivities. We always ask, well, where you're building this home, was that land once a farm? Is there still farming around the area that could affect the water table? Many chemicals that are used in the pesticides and herbicides used in farming can show up in micro amounts and might be still an issue for folks with chemical sensitivities. So in dealing with well water, you're dealing with the possibility of not only the chemicals that are in the water, pathogens that might be in water, but also things like the hardness level, the amount of calcium, minerals, other heavy metals in the water. So with well water, we'll ask people to go to the EPA's website, and you can see it here. The EPA website will talk about, you can actually put your zip code into their search engine and tell you what to look out for in your area. In our area, southeastern Wisconsin, radium is a big concern for people with wells, even from city water, we'll talk about in a second, for city wells. Radium is a big deal. Arsenic can still be a big deal. And obviously it's a huge issue for people with chemical sensitivity. If the customer says that we have city water, well, city water, for the most part, most municipalities now are using either ozone for treatment or and chlorine combination, or just chlorine or chlorides. While it's very effective for the use of cleaning, filtering, purifying the water, it doesn't always do the job. And let me give you a couple of examples. Here in the city of Milwaukee, back in the early 90s, there was a huge outbreak of cryptosporidium. And I was one of the unfortunate people to get hit with that. If there's anybody else here on the talk from the Milwaukee area, you remember this. 403,000 people roughly were affected by this. Over 100 people died, and that's because most of those individuals were folks that were very elderly, had already depressed immune systems, and they never really figured out what the cause was for the crypto outbreak. All they could say was it probably was because of snowmelt coming off of farm fields that also brought the pathogen from cattle and so forth. But again, there is no real determination what exactly came from. Current issues that we're dealing with right now in Flint, Michigan, and that's actually caused mainly by lead and in the pipes in the water, the entire water pump system. And it's also they're getting a sudden outbreak of Legionnaire's disease because of this. So with city water, I'll also then refer clients over to the World Health Organization, and they have a fact sheet about the use of chlorine specifically in drinking water. and I'll encourage you to download that. Again, I can, somebody asked about having that documentation emailed. I'll certainly send that along, a link to a PDF file. The problems with the chlorine, that it goes way beyond, though, the chlorine itself, that chemical itself. And like I say, with Flint, Michigan, you're finding out that the chlorine is actually causing a problem where it's breaking down, or the rate of corrosion of all the metal pipes associated with it is rising fast because of the use of that chlorine. So that's why the two big things, city water, well water, and the issues we're dealing with them. Obviously, with both, we're dealing with hundreds of VOCs, other chemicals, other pathogens, the turbidity of the water, without getting into the minutia of detail because of the fact that there's hundreds of items. We'll just talk about the systems that are available and allow folks to ask questions about what might be a good answer for what the problem is. So let's talk about the systems that are available for most individuals. First would be what's found most everybody's home is a water filter used in the refrigerator. Most new refrigerators that have ice and water lines have a filter now in the unit. And these filters are effective to some point. They're only designed to last about 200 to 300 gallons, possibly up to 500 gallons for some of the units, about 6 months, and they'll filter down to an average of 0.5 microns, as you can see here. They incorporate a charcoal filtration method that may or may not have a fabric wrap. This is a good secondary filter, I would say, but I usually recommend relying on a larger system, which we'll get into in a bit. The countertop filtration systems, or the point-of-use filtration systems. Again, these are typically a carbon block filter. These are also rated for about 6 months, but we'll do up to about 5,000 gallons. Keep in mind that 5,000 gallon number is based upon, specifically is based upon filtering out chlorine or chlorides. For that, it fills up relatively quickly, usually within the first 10% of its use. So it's going to filter far less for most of the VOCs and other hazardous chemicals. So again, I would call this a very good secondary type filter. These units can be effective for filtering out chlorine, chlorides for that small amount of time, but you really have to keep on top of making sure that those filters are changed on a regular basis. Point of use now for undercounter systems. Now we're getting into a system that I believe is probably the easiest, the best combination of ease of installation and effectiveness, because you can get these undercounter systems now that use anywhere from 1 to 3 stages on the average. They're far more effective at dealing with lower quality water than the refrigerator filters or the countertop filters. So they're incorporating a multi-stage filter system, activated carbon, a catalytic carbon, ion exchanges for heavy metals, small particle filters for cysts like cryptosporidium and giardia. These really would be our go-to unit for our customers who are asking for a really good quality point-of-use drinking water system. One of the questions that comes up about these systems here is the use of plastics. And I don't know if anybody's asked this question yet, but the plastics that are used in these drinking water systems are typically a polyethylene or a cross-linked polyethylene that do not off-gas, do not leach. But the question comes up all the time. For somebody who has extreme chemical sensitivities, does that get into the water itself? And the testing that we've seen done by a variety of manufacturers now that we deal with show that all of the wet parts of these units are free from any plastic like a PVC or others that could leach. And so years ago, there have been systems made by companies like Seagull and others that use complete stainless steel. The cost to manufacture these had skyrocketed, so a lot of manufacturers went away from it. The effectiveness of actually the plastic now, the high-tech plastics versus the stainless steel are actually much better. And then other things like weight, damage, replacement parts, and so forth, it just make the plastics much more obtainable and usable. Now, another point of use water system that is becoming more popular these days, I would call them the up-and-comers in the point of use systems, would be the reverse osmosis systems. Reverse osmosis systems have historically been very bulky, very difficult to install. Many of those systems required separate pumps and electricity to operate. Most importantly, or the biggest detriment of reverse osmosis systems is that they're incredibly inefficient to operate. And not only trying to be healthy, but also to be environmentally friendly about this, most of the RO systems up until the last couple of years would waste so much water. For every gallon of actual drinking water, you'd waste up to 24 gallons of water just to flush the membrane and flush the filters. The particular unit that I'm showing here is a new type of system that only uses about 2 to 2.5 gallons of water, overall water, for every gallon of water that's drinkable. It uses a new technology that it's called a circle RO system. It eliminates the need for electricity and then integrates the tank and the filters together. So it's basically a one-step, all-enclosed system. Let's see, it's uses about 2.5 gallons of water for every gallon of drinking water, about 10 times more effective. It's much faster than a traditional system, a traditional RO system, because it only uses that 2.5 gallons. It actually uses 4 separate water filtration units inside, as you can see from the back picture. So this will reduce industrial chemicals, heavy metals, pesticides, herbicides, your total dissolved solids, VOCs, microorganisms, even just simple bad taste in water, and then all the way down to the minutia of chromium, benzenes, trihalomethanes, so on and so forth. These systems are probably, you're going to see these coming on the market faster because of the technology improvements in the last couple of years. We're in the process right now of testing one of these units in our own facility, and I can say so far that we're pretty happy with how it's working. The downside to a system like this is just the cost to replace the filters on a regular basis. I mean, the filters themselves are rated from 6 to 24 months, depending on which one. And you can see you can actually install it above or below grade, or excuse me, below the counter. If anybody wants any information about the actual filters themselves that are installed in this unit, I can tell you that in this particular one, there's a sediment filter, a pre-carbon filter, a membrane filter, and they also use what they call a post-carbon block filter, and that's what gets rid of all of the chlorine, VOCs, and basically the bad taste and odor that is found in city water. Whole house systems. So everything I've talked about up to this point is fantastic for your point of use, but if you have a home that has multiple areas where people are drinking water from, or you also want to deal with water used for showering, for laundry, for washing your hands, now you're looking at whole house systems. A whole house system like this it's called a Rhino system, is effective for over 97% for the chlorine in water for up to 1 million gallons of water. So where the countertop system we talked about before is effective up to 5,000 gallons, and really only about 10% effective of that time, so about 500 gallons for chlorine. The rest, gets filled up faster. Something like this is effective for about 1 million gallons, which is about roughly 10 years worth of the average home, worth of showering, bathing, laundry, drinking water, so forth. So a system like this, too, also incorporates the use of UV to kill off almost 100% of viruses, bacteria like E. coli, chlorine, resistant cysts like crypto and giardia. One thing to consider about these highly efficient whole house systems is that they're so effective with chlorine and other VOCs that they actually improve the indoor air quality of a home. And we'll talk about home indoor air quality in a second, but think about that. Every time somebody takes a shower or bathes, the steam actually carries with it or vaporizes the gases that are found in traditional well and city water, and that can be carried throughout the home. So if you use a system, a whole house filtration system, you actually will improve the indoor air quality of your home as well. So I find that incredibly interesting, beneficial, that it does kind of work on two things at once. Now keep in mind with a system like this, you don't necessarily need then your other point of view systems. So you're cutting down on cost. I kind of have here a chart that Brett showed at the beginning of the presentation, and this shows utilization of a whole home system, helping with all of these different aspects of the home: showering, bathing, clothing, clothes washing, and the use of detergents. It can actually help improve the effectiveness and the efficiency of a water heater. It'll improve the taste of coffee and tea if you have a coffee system that's lined into the water of your home. Other dishwashers and appliances that rely on the water can improve the longevity, so on and so forth. You can see from that slide.
And can you speak to a little bit about these systems also filtering out fluorine or fluoride, and whether is that something that's important, or is there no connection to health issues with that?
Well, I can a little bit, and the sound quality was a little bit off there for a second, Brett. But let me just talk about the first thing I heard is that I'm a kind of an espresso snob myself, and I have a espresso machine that's lined into my whole house water system, and it does make a huge, enormous difference in the taste of coffee or tea when you take the minerals out of the water. It also improves the effectiveness. I know that because my system is actually hardlined into my water system, I don't have to descale the boiler every 6 months like some people do. I don't have to descale it for at least 5 to 7 years. I mean, matter of fact, my new system, I haven't even my new unit I haven't even done yet. But the taste is so much better. As far as the fluorine, fluorides, and so forth, I mean, most of the research that I have done is based upon chlorine, chlorides, and I can't speak specifically to fluorine and fluorides, except for I have had customers ask about that, and we do know that the effectiveness of the whole house system is so good with literally hundreds of chemicals that I don't think it would be an issue with that, but I certainly can do a little more research and provide some follow-up for those who are interested. I see a question here about the initial cost of installing a whole house system, and these whole house units, run anywhere from $1,500 to $3,000 just for the equipment, and then plus the labor. The labor, again, it's going to depend on whether it's new construction or remodeling. Can be anywhere from, a few $100s to, over $1,000, depending on how much, what is all involved. But it's not that difficult to install. I mean, a plumber, you're looking at, probably a half a day to install a unit like this. The difference between a filtration system and a water softener system is just that. I mean, a water softener, all it's doing is taking out the minerals of the water, where a whole house system for filtration is not only can you incorporate this into a whole house water softening system, but it also will filter out all those chemicals down to, less than 0.5 microns. So, matter of fact, the system that I'm showing on my slide here can actually, you can incorporate this into a combination water filter and softener system. So now you can start to talk about reducing overall cost because you got one product that's doing both things. This particular system that I'm showing on the slide, this tank gets changed out every 10 years. So where the main tank, where the countertop units you have to change out every 6 months, the undercounter system you have to change anywhere from 6 to 24 months. This you change every 10 years. And that's the main filtration unit, the large blue tank. That large blue tank costs about $900 to $1,000. So it's an expensive replacement, but it lasts a very long time. The small blue on the left is a pre-filter, a sediment filter, and that changes anywhere from 6 months to a year, or could be less depending on how poor the water is coming into the home.
Can you hear me all right, Andrew?
I can, yes.
Good, good. Another question that we had here was someone who's on city water, but the city is dug via wells. Is there still the same concern that you would have with, I guess you could say, decentralized well water versus well water coming from a city source?
Yeah, a matter of fact, where I live, we're on city water as well, which is why I have a whole house water filtration system. Our city water is basically just coming from a city dug well. And in southeastern Wisconsin, we have a very high amount of radium in the water and wherever you go in the area. And so we felt as my wife and I that we wanted a whole house system to eliminate that. Plus, we have very, very hard water. And a water softener system is just really not enough. It doesn't keep up with the amount of the hardness of the water, the amount of minerals and heavy metals. So we use one of these Rhino systems, and it's highly effective. So I would recommend that again go to that EPA website that I talked about earlier, and I can send a link to find out what your local water is like, basically. And then if you're worried beyond that, there are a lot of testing agencies in every region of the country that will test your water and let you know what is in it. And at that point, we can give you recommendations, or your local professional can give you recommendations. I'll just say this, and I preface this by saying I'm not an expert by any means. I'm not a chemist when it comes to this. However, we've always said that with all the products that we sell and we recommend, that the reason why we didn't sell water filtration systems back long ago is because we would let the experts deal with this. And the problem is the experts aren't necessarily dealing with it. The really good manufacturers of these products are selling online or selling through companies like ours because the plumbers really aren't giving you all options. They're giving you what their main suppliers are selling, and what the industry is sort of pushing. And so we will give you more recommendations based upon what your real needs are. And so, but first, talk to your plumber, talk to an expert in the area, and then do the research and see what will work for you. With the Rhino system or something like that, there is no wastewater similar to the reverse osmosis, because the reason why there's wastewater with the reverse osmosis is because it uses a semi-permeable membrane to filter the system. And so you constantly have to be flushing that membrane of the microparticles and minerals so that water can get through it. And so that's why there's that wastewater. With these systems, with these filtration systems, there is no membrane to be flushed, so there is no wastewater involved. All right. Lastly, I want to talk about these filtration system specialty systems that are out there. And if anybody has any questions about what we went through already or about this, I'm happy to take a question on this. The systems that I'm showing here, I'm showing a shower filter, I'm showing a water pitcher, and I'm showing just a faucet installed water filtration system. Let me just say this, water pitchers and faucet filters are basically ineffective and carry very little certifications for the use, honestly. They filter out so little from water. Basically, they'll attack what I would call the bad odor problems with water, and those are the large particles that can be captured somewhat easily, but the filters are so small and the water touches the filters so slightly and for such a short amount of time that it really doesn't do a great job in actually filtration. Most of these systems don't even have any certification to show you how effective or ineffective they actually are. The one exception I will give you to the water pitcher or the point of use specialty system is a product like a Berkey, if you've ever heard of these. Berkey. Berkey is, the best way to describe it is it's been the favorite for the prepper types, because these Berkey systems, they're highly effective. There's stainless steel tanks that use anywhere from 2 to 5 carbon block and other type of media filters inside, and it's just a gravity-fed system. So as the water filters through the carbon block and drips down into the tank below, it filters out everything. Highly effective, very portable, and they require nothing but gravity to operate. I mean, you literally could take pond water and turn it into wonderful tasting water. These units are so highly sought after that I believe the last time I placed an order with Berkey, there are about a 6-month waiting time to get one of these. Not an effective source of drinking water for a whole family, because it takes quite a while for 5 gallons of water to filter in from the top tank to the lower tank. But highly effective, especially if you want to get something that, if you're out of power for a while, this is still going to, or your city water's not working, your pump's not working, this will work. Shower filters, finally. The shower filters do work, but as what I would call a single-purpose use, obviously. Shower filters, or showering itself, as I mentioned earlier, can release VOCs, chlorine gas into the air, and make your indoor air quality affected by this. And so I always recommend shower filters, even if you have a point-of-use water filtration system for drinking, and you're on city water, I'll request that you use a shower filter for your main shower, because chlorine and other chemicals can be absorbed through your skin, and especially people with chemical sensitivity, they're highly affected by the use of chlorinated water. It's also good for, if you're living in a rental property and you don't want to put in a whole house system, it's just not feasible, not cost effective, so forth. Any additional questions about these portable units? I'm going to move on to indoor air quality. We're a little over halfway on this presentation. I want to leave time for questions and answers. Indoor air quality obviously can be dealt with in a variety of ways in a home. In our last presentation, we talked about chemical sensitivity and building healthy homes. Obviously, indoor air quality is the #1 concern we're going to deal with today. Let's talk about the type of HVAC system. Is it new construction or rehabilitation or remodeling? And then any known indoor air quality systems. Air purification, #1 issue for those with allergies, asthma, chemical sensitivities. And honestly, we'd have hundreds and hundreds of recommendations for how to reduce or eliminate many of the contaminants in your home. Air filtration or purification is absolutely necessary, and we'll get into this as we talk about the systems that are out there. So a client comes into one of our locations and says, we're building this home. We've talked about the water purification. Let's talk about air purification. And as Brett and I were talking about this earlier on about this presentation, I said to Brett, one of the things that I need to talk about is from a new home standpoint, we get this all the time from home builders. When we talk about pure air, they'll say, oh yeah, but we install whole house energy recovery ventilators or heat recovery ventilators. Isn't that good enough? Quite honestly, my opinion is, and the opinion of a lot of indoor air quality specialists out there is, if you've got X amount of dollars to purify the air in a home, and you can either afford an energy recovery ventilator to bring in fresh air, or an whole house air purification system, 99 times out of 100, I'm going to tell you to install the air purification system in lieu of the ERV. If you can do both, fantastic. But and let me tell you why. With an ERV or HRV, these heat recovery ventilators, you're sucking in fresh air from the outside to replace it with the stale air on the inside. The problem is that fresh air you're bringing in from the outside can be full of pollen, mold, ragweed, who knows what else is coming into the home from that outdoor air. Whereas that air intake located, is it drawing in pesticides that were just applied to your lawn? Is it drawing in chemicals used to treat the mulch that's used around the house and so forth? I mean, all these issues you could be bringing into your home unknowingly. Also, you have to rely on that volume of air that you're bringing in to somehow get throughout every little nook and cranny of your home. And I'd rather make sure that the air that's in the home is purified on an ongoing basis. So that's my personal sort of soapbox on that. We'd always recommend an indoor air purification system in lieu of the HRV if you had to make the choice. So there's a few different methods that we're looking at. First of all, portables. Portable systems like I'm showing here, they're using carbon zeolites, a military-grade HEPA system. And HEPA is something that you see now on any type of air purifier, vacuum systems. High-efficiency particulate arrestants is a standard term. It's talked about all the time and actually rarely discussed what it is. What a HEPA filter is, a HEPA filter was actually developed by the Atomic Energy Commission during World War II. And it was developed to remove hazardous radioactive dust from the manufacturing plants. And it's a specific type of designation. In order to achieve this designation, a filter must collect 99.97% of a particulate that measures 0.3 microns in size. This test is established by the Institute of Environmental Sciences. It's a test that manufacturers have to pass in order to give what's called a HEPA filtration certification. So a system like this, this portable air filter, it's made by a company called Austin. And I bring that up because recently, if anybody's been following what's been happening in California with the big gas incident, the gas leak of methane, the Aliso Canyon gas leak. So far, as of about a week ago, the final numbers that I've seen, because now that it's been capped, but the final number at some point around 1.2 million pounds of methane that was spewing into the atmosphere every single day. And the situation out there became so serious that the governor declared a state of emergency, and thousands of families were being affected by this through school, at their homes, and so forth. And this particular company, Austin, was the one company that they sort of leaned on because they're a large producer of a specific type of filtration system using military-grade HEPA, that they had to shut down their plant in Buffalo for selling their regularly available system so they could concentrate on that particular region of the country. And so we just got an email from them saying that, okay, well, we're kind of back up and running now, because as of just less than a week ago, they plugged the leak. But highly effective at purifying the air, anywhere from 700 to 1,500 square foot. These units are portable, so you can move them from room to room. You have to rely on the air in the home, every molecule of air going through this one system. So while it's effective in a room, if you have a 1,500 square foot home with multiple rooms, it's going to take a long time for every bit of air to go through this one system. So we recommend these as a temporary solution, but not something that you would want to rely on for years to come. Whole house filtration systems like this is actually a ducted in HEPA system. And this ducted in HEPA system uses a pre-filter, a charcoal filter. It does have that HEPA rating. Like I talked about what HEPA is, a HEPA system usually requires a significant amount of fan energy to force the air through the filtration system. So you always want to make sure that units like this are sized properly for the amount of air that you need to move in the home based upon the size of the home. And this is where you want to bring in your HVAC contractor, your heating and ventilating contractor, to make sure the unit is sized right for the home. So what happens is the system here, the polluted air, or the filter, the air on the return side, is directed through the filter on multiple passes in a zigzag pattern to cleanse the air. So working in combination of both the HEPA, the charcoal filter, and the pre-filter, it'll be able to capture larger particles. These systems usually run about 2 years before requiring the replacement of the HEPA filter. The pre-filter probably can be anywhere from 6 to 12 months. And I'll get into, in a second on this last slide, or previous slide, I'll get into some sort of optional add-ons for these types of systems. So this system here, the electrostatic air filter, every furnace filter right now that we think of, these pleated 1-inch air filters, are virtually ineffective for anything that could actually affect the health of the indoor air occupant, or the indoor occupant of the home. Those filters are actually effective for keeping large particles out of the furnace itself. So they're called furnace filters for a reason. They're actually there just to protect the furnace. They don't do much for the indoor air quality of a home. In order to be more effective for the indoor air quality of the home, it has to be a furnace filter, and we've probably, if you've done some research on these, would be a system like an Air Bear or others that use a 3 to 5 inch wide air filter. What happens with that is it reduces the airflow, which now actually reduces the effectiveness of the actual filter itself. These electrostatic air filters that I'm talking about in this picture here, it's a polarized media, so it actually installs directly into the 1-inch filter rack of your existing furnace filter. It's electronically enhanced, meaning that it actually combines both electronic and media air cleaners. It hooks up into the furnace, to the circuit board of the furnace, so it electrically charges or polarizes the media, and then it collects any particles that are blowing through it in that media. The polarized submicron particles will join with others that are going through and makes it more effective as it goes on, actually. So it's very effective in removing cigarette smoke, pollen, dust, odors, other contaminants. That polarized media is replaced usually every, it depends on the severity of the problem, anywhere from 2 to 4 months. And a unit like this is probably about $400 to $500 installed into your furnace. I'm currently testing one of these in my own home, and I'm very excited about how well it's working. And I can definitely tell a difference between going from a 1-inch, super efficient furnace filter to the electrostatic polarized units. Now, for air purification, for what I would call the ducted in or portable UV systems, a germicidal UV lamp, it's actually a whole house system that installs directly into your HVAC system, usually on the return air side, but can also be installed above the A coil if you have whole house central air system. And I have customers that have actually installed one on each, one on the return air side and one on above the air A coil, because they live in an area that's prone to more mold in their environment. And so it's super high intensity UV lamp, disinfects the air by neutralizing any airborne pathogens such as bacteria or viruses, mold. And according to the EPA, the combined use of filtration and the germicidal lamp is highly effective as means to preventing the distribution of airborne viruses. This particular unit, you're looking at about a 2-year time frame between replacing the bulb. Once the bulb starts to deteriorate after about 18 months, it'll lower the effectiveness and how well it works. So usually that 18-month to 2-month or 2-year period is where we're replacing those bulbs. These are all over the internet, these types of systems. This particular brand, others that we work with over the years, have been the most effective that have worked for our clients. And I'll talk a little bit about these systems in a second that also produce ozone, because I know that's probably on people's minds right now, that these UV bulbs produce ozone, and we'll talk about specialty air purification in a second. But these systems that also include ozone will not only control the allergens in the home, destroy organisms like mold, spores, bacteria, and so forth. They'll help to control odors, control toxins that are coming off of the building materials. Here's my thought on ozone. Ozone, the best way to cite it is a little is good, a lot is not. At high concentrations, ozone can cause issues like chest pain, coughing, shortness of breath, throat irritation, eye irritation, so forth. It obviously varies widely from person to person. However, ozone has a half-life, or O3 has a half-life of about 8 minutes. So if it doesn't actually react to something or adhere to a pollutant, it'll react to itself and turn back into pure oxygen. I like using either the portable systems or the ones like this that are ducted in specifically because you can adjust the amount of ozone that's coming into your home. The rule of thumb with ozone is if you can smell it, that tradition that if you ever smell pure ozone or pure oxygen before, a very sweet smell. If you smell it, it's up too high. It's very effective at keeping indoor air quality to a very clean point in your home, but just be careful about the units that you buy. The ones that you can control the amount of ozone, thumbs up. The ones that you have no control over, thumbs down. Specialty air purification, there are units out there that are either pure ozone, pure ionization, or a combination of the two. Let's talk about ionization now. Ionization, it's basically it's a negative ion it's an oxygen atom with an extra electron. It's odorless. Ozone is an oxygen molecule consisting of 3 oxygen atoms. So that's the difference between those two. Negative ions rid the air of pollen, dust, etc., stuff that you can see under a microscope. Ozone gets rid of odors, pollutants, and other stuff at the molecular level. So with ionization, the dust particles in the air actually get electrostatically charged, and they stick to one another and become so heavy that they fall down to the ground or to a surface. So if you use a product like an ionizer in your home, or even that electrostatic air filter that you put into your furnace duct, you'll actually notice a higher amount of dust that is collecting on tables, chairs, and floors in your home for a small amount of time, because it's actually making the filtration system more effective, so that you'll actually have to clean more in the first 30 to 60 days, but after that, that subsides dramatically. All right, that is it for the presentation on air and water filtration methods. If we have some time left, I can talk about some of the questions that are on the Q&A, Brett.
Yeah, I did want to real quick cover one thing you and I talked about. Can you hear me all right?
I sure can.
Okay, good. And that was kind of going back to your point about the HRV, ERV, which is sort of the direction we're heading in, this idea of bringing in fresh air, because the outdoor air is clearly, especially in the U.S., much cleaner than the indoor air. But some of the points you brought up are great, and then another point you had mentioned before, maybe you can elaborate on, is maybe some of the components of some ERV or HRV systems actually aiding to causing poorer indoor air quality.
Mm-hmm. All right. Definitely. This is actually through trial and error on our own with our clients over the years. I can tell you that, and again, we specialize in chemical sensitivity, so I'll usually defer to them, because they're obviously the chemically sensitive are the canaries in the mine shaft, and if it's bad for them on a small level, it's going to be bad for everybody at some point. So I remember a project a few years ago where a customer installed a brand new HRV system into their home. And this particular unit, their HVAC contractor didn't tell them that it's actually predominantly made of plastics, and plastics that actually leach into the air as the unit was supposed to be working. And within 3 days, she had to take it out of her house. And so the unit itself can actually be problematic. So you're bringing in fresh air that might be full of pollutants itself and other chemicals coming from the ground outside, but the unit itself can be problematic. So there are some systems on the market that are using stainless steel as opposed to plastic. There's a brand called Life Breath out of Canada. Very effective, but very expensive. But honestly, between the two, if I had to choose, it's going to be the air purifier over the HRV, ERV. I know there's a lot of push nationally to push the energy code so that all new homes, you have to have heat recovery ventilators. That makes sense at some level, because the way new homes are being built today, they're being built so tight, so energy efficient, which is fantastic from a cost-saving standpoint. But these homes are literally becoming toxic boxes. So you have to have fresh air in those homes. So the general thinking is, okay, well, we'll bring in fresh air from the outside. Well, is that outside air really pure enough for people with allergies, asthma, chemical sensitivities. So that's why I say err on the side of safe and use the air purifier instead. If you can do both, fantastic.
So you're saying because there are these requirements. I think ASHRAE is one I can think of, which is starting to require providing makeup air. Have you ever heard of them allowing air purification as an alternative to that, or do you think it's going to have to end up being both?
I think it has to end up being both. And here's the thing also that, I didn't touch on. And again, I'm not a IAQ specialist, by any means, but from a standpoint of a homeowner, the home's being built so tight too. You have to remember that anytime somebody puts on a bathroom fan that's ducted to the outside, or a kitchen a range duct, it's going to affect the air pressure in the home too. So I actually personally like using a HRV system that's tied into a multi-stage furnace, so that if you turn on a bathroom fan, if you turn on the kitchen range hood, it actually turns on the ventilator in your home, the whole vent system, so that you bring in air as you're expelling it to help balance the pressure in the home. So, I believe ASHRAE is looking at this from not only a standpoint of indoor air quality, but also just for maintaining the correct air balance in the home. So, no, I don't see them ever looking at you installing an air purification system as a way to get around their requirements for makeup air from a balance standpoint.
Thanks. Here's a question from the audience before we jump back over to water. How does electrostatic air cleaner compare to electronic air cleaner? Are they the same thing, or do they perform differently?
It's going to depend. I mean, it's semantics. An electronic air cleaner, generally speaking, is something that uses either an electronically charged electrostatic media, like the furnace filter replacement I was talking about, or I showed, or it's a device like I'm still on the slide here on the right. It's actually an ionizer that expels out into the general volume of the air electrocharged ions that help to connect one dust particle with another, so it eventually becomes heavy enough to fall to the ground. So it's basically this. It is the same thing, but in different methods. So I talked about a portable air purifier versus a whole house. An electrostatic air filter that I showed in this side will be much more effective for the entire home and for maintaining cleaner air ducts. A unit like this on the right is effective for maybe one room. In years past, the ionizers that were used actually electroplated dust to the wall. I remember my grandparents' home years ago, because they were smokers, they had one of these electrostatic air cleaners to cut down on smoke in the home, and it actually took that smoke and electroplated it to the walls. And nowadays, the way that these ionizers work, it doesn't do that. So it's more effective, less damage, but I'd recommend the electrostatic filter replacement.
Actually, before I go over to water here real quick, I actually just sent over a link to everybody with a quick resource, but I'll get to the question here in a second. Really, it's this idea of devices that can take a look at things like the question that came in here, CO2, or maybe TVOCs or VOCs or formaldehyde. This link I sent over for you listening live, is a LEED Platinum project here in Chicagoland that uses a device that not only moves air source heat pump air around the house for efficient air delivery system for heating and cooling, but also kicks in and removes VOCs and other particulates out of the air. So check that out there. But what are your thoughts on that, Andrew? With systems that detect certain things in the air and then kick in to remove it?
Well, it depends on how good the sensors are. Honestly, you know, most people nowadays have a carbon monoxide sensor in their home. Those sensors are not, they don't really do a good job of alerting you to low-level detection. You know, I've seen tests done on some of the household units that people buy, you know, from the hardware store that are basically detecting carbon monoxide at 10 to 15 times higher than what it should be. And it's actually way above the danger level, especially for people with already depressed immune systems, already with lung damage, with cancer, and so forth. There are a couple of brands out there, and I'll find these links for everybody and send them over. But there are a couple of brands of carbon monoxide sensors that I would recommend over the others. I can tell you generally you get what you pay for. Anything that's going to be, you know, $25 at XYZ big box is not nearly going to be effective as something that's going to be in the hundreds of dollars. But when you're talking about something that's so dangerous as carbon monoxide, you know, to me, erring on the side of safe is going to be your best bet. So I would be interested in units that would tie into a very effective sensor and then kick in. But at that point, you know, shouldn't that just be always running no matter what? A whole house filter system that is always working on those units, or, you know, a monoxide, carbon monoxide tester that would alert you to lower levels for people, for small children or for elderly adults that have more depressed immune system.
Okay, great. Do you have time to stick around for one more question?
I sure do.
Okay, great. We're going to jump back into water here again, but for those of you who got to get going, thanks for joining us. Your continuing education certificates and surveys should have been sent out. And for those of you listening live or listening on demand, make sure to take the quiz after we wrap up here to pick up your continuing education units. So I did want to jump back into one last point with water, and it was a question that that did come back up. And I just think of this idea that you know, the cost and expense of having to filter water that comes in when you know, is there a way to reduce that cost and expense? You know, if we were just using captured rainwater, you know, ideally from some kind of food-grade metal roof, because from my understanding, asphalt shingles bring in lead and all sorts of other issues. But would it be cheaper and maybe even healthier to, if legal, to utilize rainwater for purification instead of trying to filter city or groundwater?
That's a very good question, Brett. And there's a few different ways to approach this. Before I answer the question, I just want to thank everybody for attending. Obviously, you know, there's so much to talk about in these, and what I would like to do is just give people a wide variety of items that are out there, and hopefully then make that decision-making process a little bit easier. Now, regarding rainwater, rainwater collection systems is something that I have been involved in over the years. A lot of this will have to do with municipality, honestly, Brett. The municipality that you are in, some places, it's first of all, in some states, it's illegal to collect rainwater. I know that in the state of Colorado, unless this has changed recently, it's illegal to capture and use rainwater because, according to the state of Colorado, the state owns the water. So, and this issue, you know, may be a moot point, but to use rainwater, captured rainwater, to then filter, purify, to use as potable drinking water, honestly, it's a state-by-state, municipality-by-municipality issue. You have to get approval by the city or township that you live in to allow this to happen first. Second of all, is it cost-effective? Honestly, my gut feeling on this is it's not cost effective if you have to dig a well, because there's a cost involved in the rainwater collection system itself. You're looking at, several $1,000s to install a rainwater capture system large enough to use for potable water for your home. You have to have a roofing system that allows you to effectively purify the water. So as you mentioned, using like a metal roof system over an asphalt system, well, now you're talking about increasing the cost of your roofing material by 5 to 10 times. So factor all that into the cost of your drinking water, and it's probably much more cost effective just to dig a well, a traditional well, and install an air purification system. Now, from an environmental standpoint, is it a good idea to do the rainwater capture system? Yeah, you can argue it is. Keep in mind that most people, for their homes, well over 50% of the water that they'll use at their home is actually used outside of the house, washing cars, planting or watering gardens, watering the lawn, so forth. This is on the average. A lot of us are different, but on the average, over 50% of the water used in somebody's home is used outside of the home. So this is where I'd recommend kind of a dual system. It's actually very effective to use a rainwater capture system for outside water use only, because then you don't have to get approval by your city or state or or municipality for potable water. You only need to do rudimentary type of filtration systems because you're just using it to wash cars, to water plantings outside. And in a lot of municipalities, and for a lot of individuals, you can actually talk to your home insurance company and get a little bit of a home insurance deduct, because now you can actually install what they call fire well on that underwater capture system, underground capture system, and use that to tap into for fighting fires. State of California is one location where these units are being installed all over the place, because not only do they have a water shortage, but for fighting the forest fires. So I hope that kind of answers the question, Brett. I mean, it really comes down to the individual application, but my gut feeling on this is it's going to be less expensive still in the long run to do a whole house purification system from your regular well. If you want to use a capture system for your outside water, you're talking about lot lower expense for the filtration system and probably more effective.
All right, Andrew, well, thanks for your time. We're going to wrap up here today. Where can people get more information if they want to learn more or contact you?
All right. Best location to go to would be our website, a couple of websites we have, buildingforhealth.com, thegreendesignCenter.com, and from that you can log on and actually sign into our newsletter. We'll have a newsletter starting up shortly again this year, broadcasting a lot of the new materials that are coming out, also keeping you up to date with frequently asked questions, other tips and tricks on how to build and maintain a healthy home. And if you have any questions specifically to me today, or if you're listening to this recording, Andy at buildingforhealth.com, and I'll get back to you right away. Thank you very much.
Hey, Andrew, thanks a lot. Thanks for everyone, and have a good week. Take care.